Hi, this is Prof. Redder again, and this time we're going to talk about unit testing. Most things that we do need to be tested. Almost everything that we write needs to be tested in some sense. And unit testing will allow us to do a certain kind of testing that checks every little piece of code, every function that we write. And so what we're going to do is write some tests. I'll show you how to build unit tests and install testing in your application. And what I'm going to ask you to do is to perform these kinds of tasks on your application and to write a paper as usual to describe what you've done and what you've accomplished and what you learned from it. So with that in mind, what I want to do is to establish tests for these methods: the get balance, account, construction, deposit, and withdraw. We're going to leave out the construct. Well, we'll do the constructor as well. And what we want to do then is check to see that these are behaving like we expect. Now, we're going to look at really simple kinds of things here, but what's going to be interesting is that we can do a lot of different tests on one of these methods. For example, it's possible that we would want to know if a withdraw for an amount more than the balance actually worked, and so we could create a test with that purpose in mind. But for this example, this set of examples, we're simply going to check to see that these things work the way we've designed them, and we're going to do that by coming up here to account. If you recall, we put our class into a special folder that we use to do testing or to do classes in. You might prefer to call that classes, and which is fine with me. But we're going to right click on this, and when I right click on it, it's going to ask me what to do. And I'm going to come down here to tools, and we can come right down here. Oops, I'm going to have to let me scoot this up a little bit so you can see this. Whoops. Okay, so let me right click on that. I'll come down to tools here, and you'll see right there in tools, create update tests. And it will pop up looking like this, and you may want to make some checks about things here, but generally we will, for this first time, we're not going to deal with setting up and tearing down, which is what these two functions are about. So if these are checked, go ahead and uncheck them, and we'll deal with those at a later time, maybe even in a later class. But for the moment right now, we're going to have the class name is going to be called account, which is the folder that it's in, followed by the name of the class, followed by the word test. And we're going to put it in a folder called test packages. That's what this is about. So it will appear right here. We can use one of two different kinds of testing. I'm going to just use JUnit for everything in this class. And we're going to we're not going to deal with integration tests here. So we're going to just leave everything pretty much the same, other than we're going to uncheck those two. When I do that, I'm going to click OK. You'll notice now that I have a folder here called account, and in that folder we have a file called accounttest.java, and this is it right here. And so what we're going to do now is look at what it gives us for free, and you can see that it gave us a test. Right there's how it indicates that it's a test. It gives us test get balance, which is a piece of code that tests the get balance method that appears in this. So here's my get balance method, and this thing tests it. Notice that it changes the camel casing on this. It puts a lowercase on the first word, and then camel cases, even though the function's name is lowercase g, the test name has an uppercase G. Don't worry about it, just do as they suggest. But what's going on here is that it's kind of giving you an outline of what you might want to do to test this get balance method. And if you look at it, well, let's just go down through this. The first thing it's going to do is send something to the system console that says get balance. We're not going to use that because we're using this thing. Well, I guess we can use that. Let's just leave it there. All right, so now we've got the constructor being called on new account, and we have an account object that's being created based on that construction. So this calls the constructor, assigns the new object to this thing called instance, which is of type account. Here we have an expected result. Now the system doesn't know what you might be expecting from this. It just knows it's calling some function called getBalance. And as a result, we're going to have to come up with a value right here. So at this point, if we just did create this account, we know from the constructor over here that we expect the balance to be 0. If you'll recall, we put that in after the fact on the previous video. So if we come back here, we should expect that result to be 0. So we have to put 0.0f because it's floating point. Remember that Java is expecting you to make distinctions between double and float and all of those things. So just make sure you do that. And then what we're going to do, okay, so this is the result we expect instance to have in its balance field, and or getBalance to return, I guess. And this is what we're going to get. Result is what we're going to get by simply calling getBalance on this instance.getBalance. So we've got the value in two different ways. We've got it one way by simply saying this is what we would expect the result to be, and we've got it the other way by saying this is what the result really is by calling the function. There's another method then called assert, or a collection of methods called assert methods. This one's called assert equals, and what we want to say is that the expected result is the result that we got, or vice versa, we got the result that we expected to get, whichever way you want to say it. So that's for testing getBalance. And the reason that this one comes out this way is because getBalance returns a float. And so it can make some suggestions about how getBalance ought to work, and it does so. Notice though that it throws this in on every one of these tests that it proposes that you use. So it's knowing that whatever, you better be looking through this before you just use it as a test, because no matter what happens, it just says, I'm going to fail. This is just going to fail. We don't want it to fail. We want it, unless it's wrong, but we don't want it to fail no matter what. So we're going to take that code right there and get rid of it. So now we've got a test for getBalance. The test name is called test getBalance. It does this output to the system output, but creates an account, says this is what I expect the balance to be if I call balance right away, and this is the result. And so if the result was what we expected, we're going to be in good shape. So let's run this test. Let's run all these tests. I'm going to click on run and go to test file right here. And I get this window down here and it says, look at that, 1 test passed and 2 tests caused an error. And if we open this up, expand this, we can see that test getBalance passed. This test passed, meaning that assert equals turned out to be correct. In other words, we're saying I expect this value and this value to be equal. Assert equals returns that yes, they were, and as a result the test passes. But we've got 2 tests that failed, and they just flat out failed because of this. All right, but what we want to do is to do a similar kind of thing that we've done up here, but we want to do it in the context of having a deposit or the context of having a withdrawal. Adjust this or customize this for our own purposes. So what we want to do is to specify an amount. So let's say $29.18 that we're going to put in there. Notice that that doesn't like that without the F, so there's float, and that fixes that. And we created a new account, and so we now know that the balance is 0. We do a deposit, and so now we know that the amount should be $29.18. And so we need to compare this amount with the balance of the instance now. And so if we come back here and do something like this, float balance is equal to instance dot get balance, and then we check to see if the amount that we deposited is the same as the balance that we've got. So in other words, our expected amount, our expected value in the balance is amount, and so we will say here assert equals, and we're going to expect that amount is the new balance. And if we were to run it now, again, of course, we would have this failure. But I'm going to run it anyway because you get different kinds of messages here. I'm going to run this. Notice that 2 tests caused an error, and we'll see that. But if I run this now, we'll notice that we get different kinds of things here. We get 1 test passed. That would be this one up here. 1 test failed, and that would be this one right here because we left the failure in there. And 1 test caused an error, and that would be this test down here. And so the error is that this is null, and we haven't tried to, well, it's actually that we didn't do an assert. So let's get rid of this. Let's delete that. Come up here and run the test file again. And now we've got 2 tests that have passed. 1 test caused an error. So we're going to come down here and work on this one. I might as well just get rid of this right off the bat. And actually, I think what I'm going to do is just take care of all of that. Let me get rid of all of that. Oops, let me not get rid of all that. Let me get rid of all of that. I want to just grab this stuff right there and put it right there. I'll get rid of that deposit there. Now, if we were to run this again, we would expect that if we were to withdraw 2918 from a new account, we would get things have to be equal, if you will. And asserting equality between 2 floating point values is almost always considered a bad idea. We got away with it up here, but probably not a great idea. What it wants to know is that they're equal with maybe a little bit of fudge room. So if we put 0.001, that would do it for us. If they were within that amount, then since we're dealing with dollars, that would be okay. You'll notice now that assert equals is accepting that now, that it knows such an assert equals overload. I'm hoping that you have discussed overloaded functions in Programming 1. If not, you need to go read about them in Java or in C# or C++. They're the same thing everywhere. But in any case, what we would expect if we're doing a withdrawal, then we would have a new account. We would have 2918 subtracted from that amount now, and that the balance should be negative whatever we withdrew. In other words, it's going to be a negative value actually. So if we run this thing, we still get, that was silly. I ran it as an application, but I need to run just the test file. Now if I run this, I still get an account test failed. And if you look at this, it says test withdraw failed. Get balance worked, get test deposit worked. And if you look at it, we've got a copy paste error going on here because all I did was copy all this and paste it down here, and I failed to change deposit right there. And so that's something that this testing can even help you avoid, because I'm expecting this behavior to describe what happens with a withdrawal, but actually it's describing what happens with a deposit. So what I need to do is change that to withdraw. And then we'll run it again. And when you see this, all the tests passed. All 3 tests passed. And we've got passed, 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 or if you don't need to actually look at that if you've got this. And we've now done testing on our 3 methods. We could also do testing or do a test on new account, but we get kind of a test out of get balance from this. We may wish instead to do explicit testing on the constructor, which you can do by just doing this kind of thing. This is pretty much on the constructor. We need to probably do some additional tests on get balance, because what if the balance is 0 and we get it? What if the balance is negative? Do we get a negative balance? And those kinds of things. But they kind of come out because we're doing the get balance here and here. A note for you about testing. You really need to test absolutely every function, every method, if you will, that appears in your classes. There's a concept called test-driven development, which is a really great way to test things or to develop things. And it describes how to build code by simply saying, okay, I'm going to write these methods and without any guts in them. And then I'm going to write tests to say these methods need to behave so that they pass these tests. And if we write the testing specifications first and then write code in the classes until they satisfy the tests, then we've got, first of all, we know we've got testable code, and second of all, we know that it satisfies the requirements that we've set aside by the tests. Now, you may change those requirements, you may extend your testing and find that there are other issues, but this is really a pretty good way to go about building software. And so with that in mind, what I want you to do is to take your class and thoughtfully develop tests like this, and you may have multiple tests for one withdrawal. You might say test withdraw negative, test withdraw positive, and or whatever kinds of things you want. And it's kind of pushing it for these things in this introductory level stuff simply because these methods don't do a lot. But when we get to more complex methods, when you get to more complex methods, I think you'll find it valuable to be able to test these things. Notice that we're testing them without use of an application. All we've got is a class. And this is another thing that you need to think about. And that is that when you write a class, you're writing a class to describe the behavior of something that is an abstraction of some kind of thing that you're going to build. And you can test that before you ever even use it. You can write tests against that class before you ever even write an app that uses it. That's a right way to do code. That's a beautiful way to build software, because then you don't write your code, your classes to work without failure in the code. You write your classes to satisfy tests, and then you can write your code on tested software. And that's a big deal. So we'll be talking about that. So as I was saying, your job is to use this concept to build tests against the class or classes that you created for previous assignments. In particular, assignment 8. So that's all there is with this one. I'll put assignment 9 up, which will have you building these tests, and I'll ask you to write a paper to describe it as usual. Have a good day.